Alright, kiddos, welcome back. We're going to continue talking about reaction types today. Today we're going to talk about combustion reactions. These are pretty simple and they're pretty obvious, I think. In a combustion reaction, oxygen combines with a substance and releases energy in the form of heat and light. Now, oxygen can combine in this way with many different substances, making combustion reactions pretty common. But we're going to focus on those reactions that involve hydrocarbons. So that would be compounds that consist of hydrogen and carbon, and carbohydrates, which consist of carbon, hydrogen, and oxygen as well. Now, the products of combustion reactions of this type are always the same. We're always going to make carbon dioxide and water. It's that simple. Any combustion reaction involving a hydrocarbon or a carbohydrate will produce CO2 and water. So here's a pretty common example. The first one, CH4, that's methane or natural gas. That's the stuff that we burn in our Bunsen burners, reacts with oxygen to form CO2 and water. So all we need to do is balance this one. And that's not too hard. You guys are getting pretty good at this now, I'll bet. If I put a 2 in front of water, that gives me 4 hydrogens on both sides. And if I put a 2 in front of the oxygen on the reactant side, that gives me 4 oxygens on both sides. Alright, so let's try this next one. Octane, the primary component of gasoline, C8H18. It reacts with what? That's right, oxygen. To produce what? That's right, carbon dioxide and water. So let's balance this. We'll put an 8 in front of the CO2 to give me 8 carbons on both sides, a 9 in front of the water to give me 18 hydrogens on both sides. Now we have a small problem here. We have 16 oxygens plus 9 more is 25. Boy, I'm going to put a 12.5 here just for a second. That does balance it, but we don't like to use fractions when we balance equations. For right now, we like to use the smallest whole number coefficients. So let's double everything so we can make everything a whole number. So we'll put a 2 in front of C8H18, and we'll change this 12.5 to a 25. And we'll change the 8 in front of CO2. We'll change that to a 16. And then we'll change the 9 in front of water to an 18. And then if you check, everything does balance now on both sides of the equation. Okay, you try the next one. Try acetone, the combustion of acetone. So pause the video, try writing the equation, then balancing it, and then come back and see how you did. All right, welcome back. So we have C3H6O, acetone, and hopefully you reacted it with oxygen, and your products were CO2 and water, right? Now this one was pretty easy to balance. Put a 3 in front of CO2 to give me 3 carbons on both sides, a 3 in front of water to give me 6 hydrogens on both sides. That gives me 6 oxygens plus 3 more is 9. We have 1 more here, so if I put a 4 in front of O2, that will give me 9 on the reactant side to balance those O's. Now this last one, cellular respiration, you learned back in your biology classes, at least I hope you did. Cellular respiration involves the oxidation of the molecule glucose. Now that's C6H12O6. And for cellular respiration, to completely oxidize the glucose, for that to occur, we need oxygen. And the products are, you guessed it, CO2 and water vapor. So to balance this one's also pretty easy. Put a 6 in front of CO2 to give me 6 carbons on both sides. 6 in front of water to give me 12 hydrogens on both sides. And then I have 12 oxygens plus 6 more is 18. There's 6 here, so I need 12 more, so I'll put a 6 in front of O2. And that balances that. So that's the last of the 5 reaction types we need to know. Let's see now if we can go all the way back to question 1 in these notes and classify each of those reactions we did as to type. So we've already balanced them. Now we're going to try to classify them as to type. So let's go back. Boy, look at all that work we've done. Okay, here's example number 1. Okay, go ahead and take a minute and go through these equations and see if you can classify them as to one of those 5 types that we've just talked about. Now, when you do it, don't worry about this equation here and this equation. They really don't fit into those categories, those 5 categories that I gave you. So pause the video, go through these equations and see if you can classify them as to type. And then I'll come back and do it for you and we'll see how you did. Alrighty, welcome back. In example number 1, don't we have 2 elements forming one compound? Remember what that's called? That's right, that's called synthesis. Good job. In example number 2, it looks like potassium takes the place of hydrogen in the water molecule, and then hydrogen's all by itself. Yeah, that is called single replacement. Alrighty, how about the next one? Well, we start with 2 compounds. Looks like calcium takes the place of sodium, and that sodium then takes the place of calcium, doesn't it? Yeah, that's called double replacement. So for synthesis, I think I'm going to abbreviate that with an S. For single replacement, we'll abbreviate that with SR. And for double replacement on these, we'll abbreviate it with DR. Hope that's okay. All right, the next one, we start with 1 compound. Looks like we break it down into a couple of compounds and an element. Yeah, I broke it down. So that is called decomposition. So if we have any of those, and the rest of these problems, we'll just abbreviate that with the letter D. Okay, we'll skip those 2 in the middle, and then we'll move on to the next one. We have a hydrocarbon with oxygen to produce carbon dioxide and water. Do you remember what type of reaction that is? That's right. That's a combustion reaction, which we will abbreviate with the letter C. Okay, the next one. Looks like aluminum is by itself here, and it's going to take the place of hydrogen, and now hydrogen's by itself on the which took the place of aluminum. So that's right, single replacement. The next one, we have 2 elements, iron and fluorine, forming 1 compound. So if you said synthesis, good job. The next one, 2 compounds, sulfur trioxide and water, forming 1 compound. That's right, that's another synthesis reaction. Okay, the next one, sodium is by itself. It ends up being bonded to iodide on the other side. Magnesium was with iodide, but now it's by itself. So it looks like it took the place of sodium, and sodium is now in a compound with iodine. So if you call that single replacement, you got it. And then the last one, we have 2 elements forming a compound, and so that is synthesis. All right, good job. Hopefully you got all those right. All right, now let's go through some examples where I give you the reactions, mostly in words. We're going to have to classify these as to type. We're going to have to figure out what the products are, and then we can balance them. You have an assignment like this in class soon, and some kids really struggle with this, but I hope that this time that I spend with you right now is going to be time well spent and will help you tremendously when you do that assignment. So let's just get right to it here. In example A here, we have magnesium, Mg, and nitrogen. Now remember, elemental nitrogen is a diatomic element. That's N2. What kind of reaction is this when I have 2 elements that I'm reacting? Yeah, it's probably going to be a synthesis reaction. So we're going to make a compound here of magnesium and nitrogen. Now remember, when magnesium forms a bond, it's 2 positive, and nitrogen is 3 negative. So we end up forming Mg3N2. That way the charges balance. Now that's a pretty darn easy one to balance. I just got to put a 3 in front of Mg, and I'm done. So if you notice how I did that, I wrote the elements out, and I figured out that it was a synthesis reaction, and then I figured out the product of the synthesis reaction, and then I balanced it. Okay, how about the next one? C3H8 and oxygen gas. So C3H8 is a hydrocarbon, contains the elements hydrogen and carbon. Oxygen gas, that's O2, remember. That's a combustion reaction, isn't it, kiddos? So we make CO2 and H2O. To balance that, we'll put a 3 in front of CO2 and a 4 in front of water. That gives me 6 oxygens and 4 more, which is 10. So a 5 in front of O2 on the reactant side. Okay, how about letter C? All we have is one compound to begin with. That's it, just one compound. Yeah, that's going to be a decomposition reaction, isn't it? So let's go ahead and start by writing the formula of what I'm starting with, my reactant. Cobalt 2 means it's cobalt 2 plus. Oxide comes from oxygen, and that's in group 16, so it's 2 negative. So I start with COO. Now, what's that going to be decomposed into? That's right, it's elements. So we have elemental cobalt and elemental oxygen. So to balance that, I'll put a 2 in front of cobalt 2 oxide and a 2 in front of cobalt on the product side, and I should be good to go. Why don't you try letter D without my help? So pause the video, try letter D, and come back and see how you did. See you in a second. All right, let's see, we have an element here, and then we have a compound. I'm thinking that this is single replacement, kiddos, where the metal will take the place of the metal in the compound, and the metal in the compound will now be by itself. So let's write this out. Calcium Ca, copper 2 bromide. So copper 2 means it's copper 2 plus. Bromide comes from bromine in group 17, it's 1 negative. So I have CuBr2. And it looks like copper is going to be all by itself now. And that the calcium will be with the bromine. So calcium, kiddos, remembers in group 2, it's 2 plus. Bromine's in group 17 still, it's 1 negative. So we end up with CaBr2, that's an A there. And I think that's balanced as it's written. Yeah, it is. So did you get the same answer for letter D? Yeah, these are sort of tough, aren't they? They take a little bit of practice, but let's keep on plugging away. Try letter E without my help. Pause the video and I'll give you a hint. It's going to be a lot like letter D. And then come back and see how you did. All right, welcome back. Looks like we have magnesium, a metal, and silver nitrate, a compound. So I'm thinking magnesium will take the place of silver, and then silver is going to be by itself. So magnesium is Mg, silver nitrate. Silver is He plus. Nitrate's one of the polyatomics, NO3 negative. So we have AgNO3. And remember, single replacement, so silver is going to be by itself. And magnesium will be with nitrate. Now magnesium's in group 2, so it's 2 plus. Nitrate, NO3 negative. So we have Mg parentheses NO3 2. So to balance that, we'll put a 2 in front of silver nitrate and a 2 in front of the silver, and I think we're okay. Did you get that one? Yeah, I know, it's kind of hard, but with enough practice, you'll get pretty darn good at these. All right, letter F. Letter F looks like a double replacement reaction to me. Lithium chromate and barium chloride. They're going to switch positions, aren't they? So let's go ahead and write out the formulas first. Lithium is 1 plus. Chromate, that's a polyatomic ion. Let's look that up. It's not too common. We don't use it all the time. Here's chromate. CrO4, 2 negative. Barium, that's Ba, it's in group 2, so it's 2 plus, and chloride comes from chlorine. That one's Cl negative. So let's write the reactants out. Lithium chromate would be Li2CrO4. Barium chloride would be BaCl2. All right, double replacement. So the lithium and the barium are going to swap, aren't they? So lithium will be with chlorine. Li plus and Cl negative makes LiCl. And barium will be with chromate, Ba2 plus and CrO4 negative. So we'd have BaCrO4. Now to balance that, we'll put a 2 in front of lithium chloride, and that takes care of me. All right, next one, letter G, iron and fluorine. And for the product, I want you to use iron 3 plus. So this is a synthesis reaction, kiddos. We have two elements, iron and fluorine. And we're going to make a compound here between the two. So iron is Fe, fluorine is a diatomic element, F2, and I said to use Fe3 plus, and fluorine is in group 17, so it's 1 negative, so I end up with FeF3. To balance that, I'll put a 2 in front of FeF3, a 3 in front of F2, and a 2 in front of Fe. Okay? All right, try letter H on your own. See how you do. All right, this is single replacement. We have chlorine gas. Now, chlorine gas is Cl2, kiddos. It's another diatomic element. And lithium iodide. Lithium is positive 1. It's in group 1. Iodine's in group 17. It's negative 1. So we have Li. Now, single replacement, that means this nonmetal will take the place of this nonmetal. So we'll have iodine by itself on the product side. Remember, that's another diatomic element. And lithium will get together with chloride. So lithium's 1 plus, chloride's in group 17, it's Cl negative, so I make LiCl. I'll put a 2 in front of LiCl and a 2 in front of Lii, and it balances. All right, a couple more. This next one is a decomposition reaction. Do you see how I just start with one thing on the reactant side? Calcium carbonate. And then I tell you that metal carbonates, and calcium carbonate is definitely a metal carbonate, they decompose to form metal oxides, so calcium oxide in this case, and carbon dioxide. So let's see if we can write this. Calcium is 2 plus. Carbonate's a polyatomic. It's pretty common. It's CO3 2 negative. So my reactant is CaCO3. And I'm going to make a metal oxide. So the metal is calcium. It's 2 plus. Oxygen's in group 16. It's 2 negative. So we make CaO and CO2. Now, they don't get much easier than this one to balance. That's right, it's balanced as it's written, isn't it? 1 calcium and 1 carbon on both sides, and 3 oxygens on both sides. All right, the last one. Phosphoric acid and sodium hydroxide. Hopefully you recognize this as double replacement. Phosphoric acid comes from phosphate, which is PO4 3 negative. Remember, we have a hydrogen that acts like a metal with the 1 plus charge. Sodium hydroxide. Sodium's in group 1, it's 1 plus. Hydroxide's a polyatomic ion, OH negative. So let's see. We have H3PO4 as one reactant, and NaOH as the other reactant. So the H plus and the Na will both switch positions. So Na plus will get together with PO4 3 negative. So we're going to make Na3PO4. So you only need 3 of those positives to balance out that 3 negative. And let's see, H will get together with OH. And HOH we usually write as H2O, don't we? All right, we just got to balance this now. So I need 3 sodiums on both sides, so I'll put a 3 here. And I have a total of, let's see, 3 hydrogens and 3 more is 6. So I'll put a 3 in front of water, and that balances that last equation. All right, once again, this is sort of tough. It's going to take a little bit of practice, kiddos, and we're going to provide the opportunity for that in class. So I hope this video helped. We'll see you soon. Bye-bye.